What's up, guys? We are here with another transformations video, and in this one we are going to be talking about our first type of transformation, which are translations. It's just a type of transformation, but specifically we're going to be manipulating this k value, okay, in this big nasty equation. And again, we're just going to go over, don't be overwhelmed by it. We're going to go over it just one step at a time, but it's this k value that we're going to be worrying about today. Okay, so I'm going to show you a little bit in Desmos first. And then we'll do some examples up here. So here we go.
All right, guys, we're here in Desmos, and I just want to show you a little bit about how this k value, how adjusting this k value, what that does to the shape of a parent function. Okay, so I have all these equations here. I'm just going to show one at a time. So right now we just have our standard parent function of a quadratic. Okay, but with this variable here, and what's cool is Desmos can kind of illustrate for you what changing that will do. So look, if I make the k value whatever, right? You can see on the graph as I move that up from 0, you see that it just shifts the graph up. Okay, and same thing, if I move it down into a negative number, it moves it down. Okay, and observe that the shape of the quadratic doesn't change, right? All it's doing is shifting this parent function up and down. Okay, and that goes for every parent function. It's not just quadratics, right? Here's an absolute value, right? Same thing, that V shape, and it stays the same shape, but it's just shifting that shape up and down. Okay, a square root function, same thing, that k value just shifts that up and down. And then our fun one, cube root, with these as S shape, same thing, it's same shape, just shifts it up or down. So that's really what the k value does, and so we're going to graph some of these ourselves, but I just wanted you to see that first, that k value has a specific job of shifting the graph up or down.
All right, so I hope that made sense to you, seeing a little bit in Desmos. And so this says, sketch the function shown by drawing the parent function first, then give the domain and range of the function. Got 1 and 2 here. Okay, let's start with number 1. Okay, so number 1 says y equals x squared minus 3. Okay, so the first thing that we want to do is identify what's the parent function. The parent function would be quadratic, all right? Quadratic, we know that because it has an x squared inside of this equation. So when you identify what the parent function is, you almost immediately want to think, okay, what did that look like? What's the shape of that? And what were the points of that on my graph? Okay, and as you first know these, it might be helpful to have like a sheet of those next to you to remind yourself of what the parent functions look like. But eventually you will want to get away from that because it is something good to memorize. Okay, but a quadratic, right? That's that U shape, that parabola. Okay, so if you don't remember, just sketching a mini table here. You're always able to do this. You're always able to make a mini table if you forget, right? And so this is for the parent function. I'm not doing this equation yet. This is just the parent function for now, right? If they have the standard x values, the y values end up being 4, 1, 0, 1, and 4. Again, it says in the directions, draw the parent function first. Okay, so I would just want to draw the standard graph and then compare kind of the parent function graph to what this is going to look like. Okay, so if I draw that, all those points, this is the parent function, okay? This is kind of the standard quadratic graph of a parabola. But I want to now shift this, perform a vertical translation to it because there is a k value in this graph, right? K value just means a value added or subtracted on kind of apart from the x. Okay, we're going to go over what all these other transformations are and what they do later, but for now we're just worrying about a number added or subtracted kind of apart from the x. Okay, and that every time that's going to be a vertical translation. Okay, so if I do that for number 1, okay, what's that going to mean? That means, right, if I see a minus 3 outside of the x, okay, the shift or the translation is going to be shifting down 3. And so what I like to do is, right, I said that all parent functions go through the origin. So I like to start there, okay? And it's almost like you have a new vertex of your graph or a new kind of middle point because the parent function is in the origin. So if I perform my transformation to that down 3, 1, 2, 3, it goes here, okay? And then the shape remains the exact same, right? Just like we saw in Desmos, the shape of these remains the exact same even if we shift them down. So if you know what the shape of a quadratic is, right, kind of you go up 1 and over 1 to both sides. There's points there, okay? And then for these, it's kind of from the middle, you count up 1, 2, 3, 4, and then over 2. That's where these points are, right? Do you see that in the parent function, right? From the origin, if I move up one, okay, there's points, up one and over one to both sides, there's points there. Then if I count up 4 and over 2 to both sides, there's points there as well. So if the shape remains the same, and it's just a vertical shift of down 3, it's going to be the same, right? You know, the new origin or the new vertex is down here, but then it's still the same, like up 1 over 1 to both sides, up 2, or up 4 over 2 to both sides. That's still, the points are there, so the shape remains the same. Another way you could think of it is if it's just shifting down 3 and no other transformation is happening, you just count down 3 from each point, right? Down 3, down 3, down 3. That worked for the simple transformations, okay? But we're going to see that sometimes the shape of the curve does change, and so we're not able to just count down. Okay, but for the simpler ones, we are. Okay, so for these simple ones, you can just count down that many, and that's what the graph will look like. So that's what this graph looks like. X squared minus 3, just the standard parabola, standard quadratic graph, shifted down 3. Okay? So I sketched the function, I drew the parent function first, and now I need to give the domain and range. Okay, so domain and range, what would that be for this one? Okay, and again, you don't need to give the domain and range of the original. Okay, we just need the domain and range of the new one. Again, domain, I'm asking, will it extend left and right forever in both directions? And yes, it will, right? This keeps getting wider and wider. So that's going to be all real numbers, okay? Or darn, how about that? And then the range, okay, does it go up and down forever? No, it does not go up and down forever. It goes up forever, but there's a spot where it's kind of at its lowest, and it doesn't go anything lower than that. And where would that be? Well, that would be at -3, right? The standard one, it's at 0, but this, we shifted it all down 3. So my range here is going to be y is greater than or equal to -3. That's the lowest point it goes to. And it goes -3 in every y value above that. So for this one, y equals absolute value of x plus 6. Okay, so identifying my parent function first, that is obviously absolute value. And so again, once you identify that, you want to say, okay, I know what my parent function is, and I need to sketch that. I need to sketch the original, because what we're doing is kind of taking that and we're shifting it around, right? So again, the absolute value one is kind of shaped like a V, right? And it's the one that's -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. So I have my V-shaped absolute value graph. Okay, that's my parent function. Okay, but what's my shift that's happening? My shift is that plus 6. Okay, again, it's something added. That's k value, something added or subtracted apart from the x. So that is a vertical transformation or translation, and that means we are shifting up 6, right? Because it's +6 or +6. So I'm taking this graph and I'm shifting it up 6. That's what's happening. So again, I start with my origin and I count up 1, 2, 3, 4, 5, 6. Okay, so that's where the kind of the new origin is here. And then the shape remains the exact same. Okay, so it's kind of that still that V shape, but it's just all bumped up 6 spots. So you can even do that, count up 6 from each point, okay, for these simple ones. So there is our new graph, right? Just the same V, just shifted up 6 spots. Okay. So then the domain and range, what would those be? Okay, the domain, does it extend left and right forever? Yes, it does. So that is all real numbers. And then the range, okay, does it go up and down forever? No, right? Because just focusing on my pink line here, right? It's going to go up forever, but it kind of has a spot where it's at its lowest and it doesn't go anything below that, right? And so that is at +6. So we would say that y is greater than or equal to 6. All right, hopefully it's starting to make sense. I'll do a couple more examples and then we should be good. So I'll erase. All right, we got 3 and 4 up here. Let's jump into number 3, okay? Number 3 says y equals square root of x minus 5, okay? So square root of x minus 5. So my parent function is the square root. Thinking about the shape of that, again, that's our weird one that kind of, it's like a cannonball shot. We start in the middle, then it kind of goes out, up and right from that, okay? Then again, it can be helpful here too to get your table of values, okay, because these are a little different as well, because we can't take the square root of a negative, right? I kind of started with all my perfect squares. These are also super helpful to memorize. 0, 1, 4, 9, and 16. Okay, really we only need to go up to 9 because 16 doesn't fit on the standard graph. and then I take the square root of those, right? So 0, 1, 2, 3. Okay. So again, use your table if you need to as you're starting out here, but try to just memorize what the shape of these are. Okay. So here is what the square root graph looks like. That's the parent function drawn. Okay. And so then once I identify that and I draw that, then I look at this and say, okay, what's the shift? What's happening here? And again, we're just worrying about the k shifts here. So it's going to be a vertical shift of down 5. Okay, so I'm shifting this down 5 from where it originally was. So that means, again, I start with my origin point and I count down 5 from there. And I have that point right there. And then basically, yeah, every other point is going to be shifted down 5 from there too for these. Again, but it's more helpful to, I think of the shape as being the same and how relatively, like how far these points are from that origin. That's more helpful than counting down, because I promise in a couple videos we'll get to the really tough ones and you won't be able to just do the simple like counting down that many. So it's more helpful to memorize the shape of this and where the points are relative to the origin. Okay, so you count up 1 over 1, there's that point. This one was over 4 up 2, so from there over 4 up 2, and then this was at right 9 comma 3, so right 9 up 3, so right 9 up 3. There is my new graph. There is my new graph of this right here with that transformation done to it. And so now I say what the domain and range is. Neither of these are going to be all real numbers, okay? So what are they? Okay, again, x. I'm asking, does it shift left and right forever? No. Okay, so that means we ask, okay, where does it stop? What's the limit to that? Okay, so again, x values, right, kind of starts here and then goes to the right forever, meaning it's going to go to positive infinity, but it's not going to go to negative infinity. So we want to identify, okay, what is the lowest x value that it goes to? And that would be here at 0, right? It doesn't go anything, doesn't go into the negatives at all, okay? So my domain here is x is greater than or equal to 0. And then my range here, same question. Does it extend up and down forever? No. Well, where does it stop, right? It's going to creep up forever as this keeps going, but it does not go down forever, right? Again, same thing. This is kind of the lowest point that it ever goes to. I would say the lowest point is -5. It's the lowest value, and it's every y value higher than that. So y is greater than or equal to -5. Okay, that's my range. Alrighty, last one here, number 4. Number 4, y equals x cubed plus 1. X cubed plus 1 means this is a cubic parent function. Okay, so drawing that, again, that's kind of my weird curvy shape. Okay, so that is -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. There it is. There's my curvy line. That's my parent function of a cubic graph. What do I shift that? How do I shift that? Well, I take that, right, and I look at my k value. That's +1. So that means I shift this all up 1 spot. So it's an easy little shift. And again, I start with my origin. Okay, you might be thinking, oh, Mr. Jones, don't make this too hard. Just count up from each point. Again, but these easier ones you can, but I promise you, get used to the shape of these. Learn the shape of these, okay? So from this origin, right, there's a point down and left from there. There's a point up and right from there. And then it's up 8 over 2. So up 8 over 2, and then down 8 over 2. There. So you see it's similar. There's some overlap here, so my blue marker is going to get all messed up, and that's all right. So there is the shift of just up 1, okay? So very similar. But lastly here, given the domain and range, okay, so the domain here, again, I'm asking, is it going to extend left and right forever? And it doesn't look like it, but it is. It is going to shift, or not shift, but it's going to go and extend to the left and right forever, okay? So it is all real numbers. In the range, yes, it does go up and down forever as well. So that is also all real numbers. All righty, there are some vertical translations for you. I think the easiest of our transformations that we'll do, okay? Next video, we're going to talk about that h value and bring some of those into it as well, okay? So good job. There it is. Thanks for watching.